we're changing things up a little bit. I wanted to record a video for you all as I was walking to my car, but it actually just started raining a whole bunch, so I decided I would just record this video while I try to leave campus and get on my way home. I'm trying to do something a little bit different this time. I'm trying to basically combine the newsletter and the AI podcast into one single video, and so I have a much shorter update for you all. The main thing is at the end of this video, that's where you're going to see your AI podcast. I'm also, in the D2L announcement associated with this video, going to include a link to the MP3 in case you just want to download the audio and take a look at it, but it's a really good one. It's based off of today's lecture on bone growth and development, where we talked about Wolff's Law, where we talk about bone remodeling, where we talk about growth and the epiphyseal plate. So it should be a pretty good podcast. All right, let's just make this turn safely here. So another thing that I'm going to include for you all are AI-generated study guide questions. These are going to be in addition to the study guide questions I have already provided you, but these are specifically on this lecture on bone growth and development. I have like 10 questions that you can answer with 2 to 3 sentences, and I think if you can answer those questions and really understand why I'm asking those questions and the information you need to know, you'll do great on the exam. Okay, so those are the last 2 things I have for you all. Again, the video will show up in just a couple seconds. I need to go focus on driving and be safe. Have a great weekend. I'll see you all on Monday.
All right, so bone growth, right. You've given us this really cool audio lecture all about it. So today we're diving deep into how our skeletons, actually build themselves.
It's way cooler than just like a boring old skeleton in a classroom.
Totally. It's not like a static thing. We're talking like living, changing, constantly adapting structures here.
Yeah, exactly. And what's fascinating is how these seemingly simple things, bones, go from just a bunch of cells to this intricate framework that like literally holds us up.
Right. When I first learned about this stuff, it blew my mind. Like, how does a bone even know how to grow? Like, where does it even begin?
Well, there are 2 main ways that bones actually form. Intramembranous ossification and endochondral ossification.
It's key names.
Right. Most of your bones, they use that second with the endochondral ossification. We'll get to that.
Yeah.
But first, I think it's interesting to talk about the exceptions.
Right, because there are always exceptions. In this case, it's the skull and the clavicles kind of doing their own thing with this intramembranous ossification. What makes those bones so special?
That is a great question.
Yeah.
So, unlike most bones, which use a cartilage model, like a blueprint, the skull and clavicles, they form directly within a membrane. They kind of skip that whole cartilage stage.
So they just appear.
Well, not exactly. It all starts with these incredibly versatile cells. They're called mesenchymal cells.
Mesenchymal cells, okay.
Yeah, you can think of them as like the stem cells of our skeletal system.
Oh, okay, so like a blank slate. They can kind of turn into whatever the skeleton needs.
Exactly. And in this case, these mesenchymal cells, they transform into osteoblasts, which are like the master bone builders.
Okay, so those are our builders. So how do they actually go about building the bone? What are they using?
So they produce and lay down a special kind of matrix. It's a mix of collagen and some other proteins. And this is where it gets really cool. As they're laying down this matrix, they basically trap themselves in it.
Wait, they trap themselves?
Yeah.
That doesn't sound good.
It sounds counterintuitive, but it's all part of the plan.
Okay.
This trapped feeling, it's actually their cue to transform again, this time into osteocytes.
So they go from being the builders to actually being like part of the structure itself.
Precisely. And those osteocytes, they're really important. They're like the communication hubs within the bone, making sure that everything's running smoothly.
So that's intramembranous ossification, going from those mesenchymal cells to building the matrix, then actually becoming part of the structure.
Exactly.
That's how we get that like protective spongy bone inside our skulls.
That's right.
Pretty incredible stuff. But that still doesn't explain how bones actually grow longer, right?
That's a great point. Because, I mean, imagine if we were born with adult-sized skeletons.
Oh, I'd bump my head a lot more.
Right. So for most of the bones in your body, growth happens at a special place called the epiphyseal plate. You've probably heard it called the growth plate.
Growth plate. Yeah, isn't that what like your parents always tell you to like be careful not to injure when you're a kid?
Exactly. It's a zone of cartilage that's near the ends of long bones, and it's absolutely essential for bones to grow longer. And it's basically like a construction zone.
Huh.
The cartilage there is constantly growing, pushing the ends of the bone further and further apart.
So it's like the bone is constantly playing catch up with this cartilage.
That's a great way to put it. Now, within this growth plate, there are distinct zones. and they each have a very specific job. It's very organized.
Oh, wow.
That way, everything happens in the right place at the right time.
Okay, so we've got this growth plate. It's like super active, right? Pushing the bone to get longer. But I'm guessing it's not just like a free-for-all in there. What's keeping everything in order?
You're right. It's incredibly organized. It's like, think of it like an assembly line, almost, with different stations within the growth plate. And each zone has a really specific role in the whole growth process.
Got it, got it. So let's break it down. Let's break down this bone-building assembly line. What's happening at each station?
All right, so picture this. Right at the very top of the growth plate, you have the resting zone.
Okay.
These are like the new recruits, the cartilage cells that are just hanging out, not really actively involved in the growth process yet.
Got it. So just chilling.
Yeah, exactly. Just kind of chilling. Below that is where things start to get a little bit more active. That's the proliferation zone.
Proliferation. Sounds important.
It is. This is where those cartilage cells, they're in a frenzy of activity, constantly dividing, pushing those bone ends further and further apart.
Oh, wow. So this is like the engine of bone growth. This is where it's all happening.
This is where things are really starting to take shape. And then as we move down the assembly line, we get to the hypertrophic zone. This is where things get, things get big.
Okay.
The cartilage cells here, they get really, really big really fast.
Okay, so they're bulking up.
Yeah, like they're bulking up for a big game, exactly.
So they're not just dividing, they're actually like getting bigger, stronger?
Yeah, they're getting bigger, they're getting stronger. And all that extra size, it actually makes the cartilage more robust, which is really important for the next step in the process.
Okay.
Because now we're getting to the calcification zone.
Calcification. All right, so things are about to get real.
Things are about to get real. This is where that cartilage starts to harden. It's almost like it's preparing itself to be replaced by bone. And as it hardens, it forms these sharp, almost jagged structures. They're called spicules.
So wait, the cartilage is turning into bone in this zone?
Not quite bone yet, but it's getting there. And this is where our bone-building friends, the osteoblasts, they make their grand entrance.
Okay, the osteoblasts. I remember those guys, the builders.
Yes, the master builders.
What are they doing here?
They're coming in to do what they do best, but before they can actually start building, there's another type of cell that has to do a little work first. The osteoclasts.
Osteoclasts. Okay, what do they do?
So think of the osteoclasts as like the demolition crew.
Okay.
They come in and they break down that calcified cartilage. They're clearing the way for the osteoblasts to come in and do their thing.
Got it. So it's like 1, 2, punch.
Right.
You got the cartilage hardens, the demolition crew comes in, clears it out, and then our builders come in.
You got it. It's a beautifully orchestrated process. The osteoblasts get to work laying down new bone on top of that calcified cartilage framework. And just like that, that's how your bones grow longer.
Wow.
It's all about this chase, this constant chase between the cartilage growth and then the bone formation.
That is incredible. And all of that is happening in our bones right now.
Right now.
Making sure they grow at the right pace and the right direction. That's wild. But hold on a second here. Bones, they don't just grow longer, right? They change shape too. I mean, my face definitely does not look the same as it did when I was like 5. Thank goodness, right? So how does that happen? How do bones actually remodel themselves?
That's a great observation. And you're right. Bones are constantly remodeling themselves.
Really?
All throughout our lives. And this isn't just about, fixing broken bones. It's a continuous process of breaking down old bone and building up new bone.
It's like our bones are constantly under renovation, always adapting to, I don't know, whatever we're doing, I guess.
Exactly. And it's all thanks to that delicate dance between those osteoclasts, our demolition crew, and the osteoblasts, our master builders.
So it really is like a never-ending construction project happening inside our bones.
Pretty much.
But what's the point of all that work? Why break it down and rebuild all the time?
Well, in a nutshell, adaptation. Our bones are incredibly dynamic. They're constantly responding to the stresses, to the demands that we put on them. People always say, exercise is good for your bones. Well, this is why. It all comes down to a really important principle called Wolff's Law.
Wolff's Law? That sounds kind of ominous.
It's not ominous at all, I promise. It's actually pretty cool. Wolff's Law basically states that bone grows and remodels in response to the forces that are placed upon it. So the more you use a bone, the stronger it gets.
So that's why weight-bearing exercise is so important, especially as we, get older. It's like we're sending a message to our bones to stay strong.
Exactly. And it's not just about overall strength either. You remember that study we were talking about earlier, the one with the tennis players?
Yeah.
They found that the tennis players, they had much higher bone density in their dominant arm compared to their non-dominant arm.
Oh, right. Because they're constantly, hitting that ball serving.
Exactly.
So all those years on the court were good for something. But it's not just about building stronger bones, though, is it? Bone remodeling has another pretty important role, right? Something to do with calcium.
Absolutely. Bone remodeling is also crucial for maintaining our body's calcium balance.
Okay, so that glass of milk my mom always made me drink, it wasn't just about strong bones.
Nope.
It was about my entire body.
You got it. Bone acts like a giant calcium bank for your body. And calcium is essential for so many things: muscle function, nerve function, even your heartbeat.
Wow. Okay, so bone is way more than just like scaffolding for our bodies. It's like this dynamic organ that's constantly adapting and contributing to our overall health.
Exactly.
So we've got these calcium banks, right, inside of us, making sure we've got enough to keep everything running. But what happens if that balance gets thrown off? What happens then?
Well, that's a great question, and it's a really important one because when that balance between bone breakdown and rebuilding gets disrupted, it can lead to problems.
Right.
Like osteoporosis, for example.
Osteoporosis, right. That's when your bones get weaker, more likely to break.
Exactly. And we often associate it with aging, but it can be caused by other factors that kind of mess with that delicate bone remodeling cycle. So basically, the osteoclasts, our demolition crew, they're breaking down bone faster than the osteoblasts can rebuild it. Or the osteoblasts slow down. They can't keep up with the natural breakdown process. Either way, you end up with weaker bones.
It's like you were saying before, like a construction crew.
Right.
If the demolition team is too gung-ho, or if the builders are moving in slow motion, the building's in trouble either way.
Yeah, I like that analogy.
Right.
And it shows why, a healthy lifestyle is so important for strong bones really throughout our lives.
Yeah.
We've got to give those bone-building crews the best chance to succeed.
So weight-bearing exercise, a healthy diet, lots of calcium, vitamin D. Got it.
Exactly. You're giving your bones what they need, the tools, the resources to really thrive. Because this whole bone remodeling thing, it's happening all the time.
Really?
It never stops. It's how they adapt, repair, stay strong.
Wow. It's really kind of mind-blowing when you think about it, that our bones aren't just these, static structures. They're constantly changing, adapting, responding to, well, everything.
Exactly. And that actually brings us to a really interesting point, especially when we think about how we live today. If our bones are always changing, based on how much force we're putting on them, what does that mean for people who, maybe live more sedentary lives?
Oh, that is a good question, and kind of a scary one, if I'm being honest. If they kind of thrive on all that movement, that stress, what happens when we're not moving as much?
It's definitely something to think about. We know bone density naturally declines with age, but not moving enough, it can really speed that up.
Oh, wow.
So it's even more important to stay active, challenge our bones, especially as we age.
Yeah, keep those bone-building crews busy. So, wow. All right. Let's recap what we learned today in this whirlwind bone journey. We started with those two main types of bone formation: intramembranous, the skull and clavicle exception, and then endochondral for most other bones.
Right, and then we talked about that amazing process of bone growth. Cartilage leading the way, bone formation chasing after it.
All happening at that growth plate, which we should probably be careful not to injure.
Definitely.
And then there's the constant remodeling, happening all the time. Osteoclasts breaking down the old bone, osteoblasts building up the new, all working to adapt to stress, maintain calcium, even repair those tiny little microfractures we get from, just living.
It's amazing. A beautifully orchestrated process that shows just how dynamic and adaptable our skeletons really are.
Our bones are like little cities,
Yeah.
with construction and demolition happening 24/7. It really makes you appreciate these, seemingly simple structures in a whole new light.
Absolutely. And it should encourage all of us to treat our bones with care.
Exactly. So keep those bones strong, keep those brains curious, and thanks for diving deep with us.